Today we will start looking at the grasp patterns. This is the focus also in the book in designing, and it's more low-level design work than previously. So, a new domain, a new example program to develop. It's a card game. If you're familiar with the blackjack game, you could maybe see that it is a blackjack game. So we're moving away from the dull dice games to card games now. And you can see here that we have conceptual classes such as card, and we have a deck that contains 52 cards, and we have a dealer that has a hand that consists of 2 or more cards, and a player that plays against the dealer, and we have some rules and stuff like that. So it is indeed a blackjack game. So we will be doing this for as the example application, but we will have some limitations. We will only use one deck. This is mainly for debug purposes. It's easier to know if we have made some mistake and added duplicate cards, for example. So if 2 ace of spades seem to get into the game, there is some error. If you have more decks, it will be harder to debug. So this is one limitation. We will just use simple rules. There's only kind of like 2 interactions the player can do. He can hit, that is get a new card, or he can stand and let the dealer play. There are quite a few variations and more complicated rules in blackjack. But we won't be doing any of these right now. We will also limit ourselves to 1 player, so no multiplayer here. We won't have any betting, no money, and you won't be doing any real gambling here. And we can always check Wikipedia for rule variation. So you can check this out, read the rules for yourselves, and this is the basic interaction that we will be doing, hit and stand, but there are others also, double down, split, surrender, making insurances, and a lot of interesting variations to the game that you can take a look at. So, if you want to know more about blackjack, you can read up. Our basic requirements to start the game, to play the game, and to quit the game. And we have some details in these requirements. The dealer should get a new deck of cards when we start the game, and he should shuffle them, put them in some kind of random order. We should display information on how to play to the user. When we play the game, the dealer should deal cards to the player and to the dealer according to the rules. If the player selects to hit, the dealer deals him a new card. If the player selects stand or has a total score over 21, the dealer plays according to some rules. And the final result is presented. And quit the game is not that advanced, so no details there. We have some requirements. We have a domain model. The next step in our process is to create or update our high-level design, our architecture. In this case, well, it won't be that advanced, because I will just simply decide that we should use the model view controller architecture. So let's just get something up and going. So basically, we will create 3 packages, model view and controller, and we will put our different, more low-level classes inside of these packages. And this program is just some small, lightweight development environment I found. It seems to work. It's not perfect, of course. You probably have better ones yourselves if you want to do Java for the course. I think that's about it for the architecture. All done. to add some details, maybe we should decide that, well, we are aiming for a supervising controller architecture, so that the controller is the conductor of the events and tells the user interface what to do, actually, and collects the information from the user interface on what the user has done, and then uses this to do stuff in the model, get information from the model, and send it back to the view. So it will kind of like conduct the different use cases we have. So it will look quite similar to the dice game that we've already done. Step number 3 done. Next step is to design, implement, test, and deploy. And actually, I don't really mind in what order 4, 5, and 6 are done in. You should probably do number 7 after we have done number 4, 5, and 6. But you can of course do it in maybe some kind of a logical way. You design something first, and you then code it, and then you test it. This is kind of like the traditional way of doing stuff. But you can of course test first, then do some design, and then implement. Or you could implement first, do some design, and then test. It's really up to you how you select to work. As long as you don't spend too much time on any of these steps. So spending a lot of time, 4 or 5 days doing design, and doing a very, very detailed design for all requirements, well, chances are that you have missed something, and you find this out when you do some implementation, and your whole design kind of like breaks. So spending too much time on any of these steps before moving on is quite risky. So that is not something that I recommend. So design a little bit, implement a little bit, test a little bit. That will probably be the order of work during the lectures, at least. This is also not a course in testing, so we will be just doing some basic manual unit testing, no automatic stuff here. So test first is maybe a little bit hard for us to do. As you have seen, we have actually coded a little bit first during the dice game. And then we have kind of like taken a look at the diagrams. And this is fine, I think. If you're a good coder, you probably have some rough idea on how to do things. But doing design afterwards can give you more of an overview, and you can find interesting refactorings and stuff like that to do if you take the time to do this. And sometimes you also kind of like find these, this is some strange things in the implementation. So sometimes you can see bad design decisions kind of like crop up in the implementation also. So if you decide to design first or to code first and then do some kind of refactoring work, it's totally up to you. So don't spend too much time on any step before moving on, and make sure you iterate. And we will be using the GRASP patterns. So the GRASP stands for General Responsibility Assignment Software Patterns. And when he talks about responsibility in the book, he thinks about two types of responsibility. You can assign the responsibility of knowing stuff. That is, someone needs to know the value of the dice. Someone needs to hold that. Who should have the responsibility to hold that value? Naturally, we selected the dice class to do this. So that is that kind of responsibility. Who should be responsible for holding this data or information that we have? Often you can find this also in the domain model. So your design can take inspiration from the domain model, and that would be a good thing. More interestingly, maybe, is the responsibility of doing things. Where should we add functionality? Who should be responsible for executing the requirements, for doing all these things that we have in our requirements, and finding good places of putting that functionality in? That is maybe the bulk of the grasp patterns meaning. And this is all something that is called responsibility-driven design. Thinking about, okay, we have this responsibility, we have this requirement to do this stuff. We can divide that requirement into different functions, and these functions should be put somewhere. They should be put in some place in the code, in some class in the code, and who should have the responsibility of executing that function. And we can then use these grasp patterns to find good candidates and to use experience from other developers on how to assign these responsibilities to different parts of our application. So these are the patterns that we will be talking about: information expert, creator, controller, low coupling, high cohesion, indirection, polymorphism, protected variations, and pure fabrication. Let's take a look at the requirements. And you should always find a good requirement to start with. And well, it will be very hard to do something about requirement number 2 and 3 before we have actually done something about requirement number 1. That is, to start the game. So this is the first requirement we will do. And we can see here in 1A that, well, we should have a dealer. The dealer should get a new deck of cards, and he or she should shuffle them, mix them in some random order. So this is what's supposed to happen. We can use our domain model as inspiration, so try to keep this one also in mind. And we find conceptual classes here for dealer, deck, and card. So that won't be maybe that hard. In the book, he suggests us to do sequence diagrams first, to show how this requirement plays out in the application, and using this information then go towards making a class diagram. So in the sequence diagram, we have objects that execute, functions gets called, operations gets called, messages are sent between these objects, and stuff happens. Using this information, we can then generate or find how the classes actually are connected or must be connected. I myself actually don't do that much interaction diagrams when doing design. I learned it kind of like the opposite way. You first do class diagram, and then you can kind of like test run your class diagram. So I don't mind if you do that also. But he has a point in the book in doing sequence diagrams first, and that is when you do class diagrams, you have a tendency to over-engineer things. You have a tendency to add more things than you actually need to this specific requirement. And that could, of course, be problematic because you spend, well, time speculating on future requirements and stuff like that that might change. So we will do it by the book, at least to start with. The first thing that should happen is, well, we need a dealer. We have the conceptual class of a dealer, so it's probably likely that we will have a dealer class here also. So this is what the sequence diagram looks like. Time flows downwards. So time is a dimension in this type of diagram. And we need to start by creating a dealer. This is a special message actually that's called create, and it should go into the box of the object. We have an anonymous object here of type dealer, so we don't have a name before the semicolon. You can add names also if you want to. And this kind of like box-like structure here, the two parallel lines I've drawn, is the lifeline of the object. It shows that, well, it has the focus of execution right now, and it won't die, this object. We create it, but it won't die. And this first message, it does not have a sender, so it's an anonymous message. Anyone that can create a dealer. It's not important right now to show who sends this message. And later in the implementation, depending on what you use to implement, the create message will be translated to some kind of constructor call. Often it's new. In many languages, it's just a new message. So somewhere we will call new dealer. What should happen next? We should get a deck of cards. So let's create a deck of cards then. Deck. New object. And a new create message. What should happen next? Well, we need to kind of like add all the cards into the deck. So we need to create a bunch of cards. And to this constructor we need to send something. We should create a combination of all color and values, of course, so that we get a complete deck of cards. So if we create a card, well, we need to assign it a color and a value. And we will get an object. I've named this object C this time, for card. And it is of type card. And we should also, of course, create all cards. So let's loop this. Then you can do a small frame here to kind of like tell that, okay, this sequence of calls, this sequence of messages should be looped. And we also added a explanation on how to loop. So we should, for every color and value combination, we should create cards. And we actually need to do one more thing here also. We just don't need to create them. We should probably also add them. So we can then create a new message, and I think also if you're supposed to be really, really picky about it, suppose to look like that. So we can call ourselves. The deck object calls a method in itself, supplying an argument C, and we know that C is this newly created card, and something happens in there so that the deck saves the card in itself in some way, and then we can be done. So, and the final step was to shuffle. So, something like that. That is maybe the first sequence diagram in this application. As you can see, it's get a little bit messy. It's quite hard actually to, if you forget something, it kind of like can mess up your layout and you need to erase a lot of stuff and things like that. So, there are some programs, I think this Visual Paradigm, you can do this also. It looks a little bit better, but and maybe it's a little bit easier, but at the same time it's also quite cumbersome to get things right here. So this is how it looks in Visual Paradigm. Taking this diagram into account, we can now create a class diagram. What classes do we have? Dealer, deck, and card. So we're dealer, deck, card. So now we're doing a class diagram. These are classes. In this one we had objects of type dealer, of type deck, of type card. What relationships are needed? Well, we can take a look at the messages, where messages are sent and to whom they are sent and from whom they are sent. So the dealer needs to send some message to the deck to create itself and to shuffle it. So some kind of relationship between dealer and deck is needed. Also, we need to have some kind of relationship between deck and card, because they are supposed to be created, they are supposed to be added, and they are probably supposed to be randomly sorted or something like that in here. So let's start with this relationship between deck and card. What kind of relationship should we have? We need to have some kind of relationship between deck and card. Which one do you think we should select? We can select dependency. That is one option. What other option do we have? Association. So, dependency or association. Well, we do have actually inheritance, specialization, generalization, and interface implementation, also realization. Those do not really apply here because we cannot really say that a deck is a type of card and card is not an interface at all. So those two kind of like fall away immediately. So we have to select by association or dependency. What is the actual difference between these two? The difference is that if we select to use an association, we will implement this as an attribute inside the deck class of some kind. And this means that we can use the cards that we can put in this attribute in other operations. So, for example, if we select association here, we put the cards that we add inside a list, array, or something inside the deck class, and we can later use these cards to do stuff. For example, shuffle them. If we do not select association, we kind of like can create the cards, but they will be destroyed as soon as we leave this constructor. So in this case, it's, well, maybe not obvious, but it is needed to have this as an association, because we need to store the cards inside the deck so that we later can do stuff with them. We can pick them from the deck and hand them to the dealer or hand them to the player and stuff like that, and we need to shuffle them also. So in this case, we need to put an association here. Where should the arrow be? Should the arrow be at the deck side of the line or at the card side of the line? Well, we can take a look at the sequence diagram again. And we can see that, well, deck sends messages to card to create them. So we need to have the relationship that deck knows about card, and the arrow should be here. Card has no knowledge about the deck, but the deck has knowledge about the card. And we could also see that maybe we should have this at the star here to denote that we can have many cards. In the domain model, if you paid really good close attention, it said 52. Maybe this is just at one point in time, so to speak, a deck has 52 cards when it's brand new. We will probably remove cards from it to give to the dealer and to the player later on. And also when we created it will actually be 0. So it will be populated a little bit later. So adding this 0 or many star is probably the best idea. We should also give it a role name. I have no real cards. M_cards will be the fantastic role name. We should always strive to get maybe better role names, but in this case I think it's not that confusing. So the next step is to take a look at, well, card sends no messages to anyone right now, at least, so no arrows going out from the card class. Deck, well, we have taken care of this one, and this is just a self-reference to the same object, so we don't need to add anything for that. Here we don't really know what will happen. Dealer is the next step. Well, it sends a message to the deck and another message to the deck. So some kind of relationship between dealer and deck is needed. And as you probably guessed, we can select from either the association or the dependency. And actually in this diagram right now we don't have any real help in the relationship between deck and card. We can see that, well, we will probably need the same cards later on in the shuffle, so we need to store them in an attribute so we can access the cards later on. In this diagram right now we don't actually see that the deck is used anymore, but we could probably take a guess that, well, when the dealer or player selects to hit and get more cards, well, the dealer later on needs to fetch stuff from the deck, and it would be a little bit strange if he created a new deck for every kind of interaction that is needed, especially as we don't want any duplications of cards here. So we will opt for an association in this relationship also. And again, where should the arrowhead be? Deck, deck, deck. Yeah, absolutely. Messages are sent to the deck, and that's about it. I will also give it a role. M_deck. So I think that's about it for now. Where should we start to implement? Card should be the first class, but why? It has no dependency. Exactly. This one is completely free right now from dependencies to other stuffs. So if we select to start with a deck, well, then we need to kind of like okay, we need to code something that won't kind of like work because we don't have any cards. And the same thing with the dealer. We cannot really implement and test the dealer before we have the deck, and we can't do the deck before we have the cards. So this could be a natural way of doing stuff. I'm not saying you should always go to kind of like the bottom. Some people like to implement from top down rather, so it's more a matter of taste, but it could be a logical step to start with the card class. The actual first question we should ask ourselves is where should we put it? Should it be in the controller, where I happen to put it right now, model or view? Model, we have some suggestions of model here. Why should we put it in the model then? We will probably display cards. Why shouldn't it be in the view? It holds data that are used to execute the rules of the game. There might very well be a card class in the view that is responsible for showing cards on the screen in some nifty, fancy way. But this card class that we are designing right now has to do with the rules of the game, execution of the business rules, so to speak. And also we could see that this was a concept in the domain model. And these often happen to go inside the model in the implementation then also. So we have actually been doing modeling in our, we have been designing in our model package. And it's a little bit confusing because model is used quite often. So maybe we should just point this out also, that we are in the model package. And doing our design. So probably just